friends. Okay, so we are going to very quickly run through the EM spectrum and what all the parts are, how to use it, and why it's important. But first, you need to know what a wave is. So a wave is a transfer of energy, and any kind of energy. We're specifically looking at electromagnetic radiation energy, but oceans have waves. They transfer mechanical energy. Sound waves transfer sound energy, and they all have the same properties. So if you look right behind me, these are waves. These are longer waves, and these are shorter waves. But they have the same properties. So the distance between the two tops of the waves, or the two bottom parts of the wave, the crest and the trough, is called the wavelength. The number of waves that can pass through a point in 1 second, like let's say that's the time block of that is 1 second, is called the frequency. You'll notice that these two waves are a little bit different. These are longer waves, these are shorter waves. So that means that the frequency of this wavelength is low and the frequency of this wavelength is high. When you have a short wavelength, you have high frequency, and you have a long wavelength, you have low frequency. And because this is a transfer of energy, that also translates to how much energy you have. So when you have short wavelengths, your frequency is high, your energy is also high too. It's a large transfer of energy. And then vice versa with longer wavelengths. So EM spectrum. Let's look at the diagram here so you can see this, see what I'm talking about here. So these properties that we just talked about are also, you're going to see it here with the EM spectrum. The EM spectrum is a spectrum of electromagnetic radiation. We use the EM spectrum to find out information about other things in space, nebulas, stars, galaxies, that we can't otherwise know of because they're so far away. All celestial bodies emit this kind of radiation, and so we can use that information to find out more about the place that we live. The EM spectrum has 7 types of radiation. It begins with radio waves. You get that in cell phones, computers. If you've ever seen like the really, really big disc satellite telescope things on Earth, those are radio telescopes. Those are the lowest frequency, lowest energy, longest wavelength. Then it increases to microwave, infrared waves. It's hard to say. We feel as heat, although some animals can see in infrared. Visible light. These are the colors that you see. This is the only type of EM radiation that humans can see. Then UV rays, which of course if you get too much UV radiation, you get sunburn. If you get way too much UV radiation, it can cause cancer. X-rays can see through things, but it can't see through bones, so that's why your doctor uses it. And then gamma radiation, gamma rays are used in cancer treatments, MRIs, CAT scans. I believe somewhere in between here is where you would use those kind of radiation. And radiation treatments obviously aren't, because they don't get used frequently, not like an everyday doctor's visit, because what do you notice about the waves here? They're really short, so that means their frequency is really high, which means it has a lot of energy, and that could be damaging to your cells. So the last thing that I'll say is EM waves have a very specific wavelength and frequency, so that you only get, if a wavelength has a specific wavelength and frequency, it is only that particular kind of EM radiation. So radio waves, for example, if the wavelength was 10 to the 3rd power and the frequency was 10 to the 4th power, then it would be a radio wave and not a visible wave, and we wouldn't be able to see it. So lost my train of thought. That's about it for EM spectrum. I think I covered pretty much the basics. If you have any questions, let me know. And then to finish out the video, I would like you to just kind of ponder on these questions right here, especially this one. Is there a pattern between wavelength and frequency? And also, what pattern do you notice about the temperature in terms of energy?